We will be studying canals in this presentation. The details are discussed in further slides. Let's begin. Canal is an artificial channel, generally trapezoidal in shape, constructed on the ground to carry water to the field, either from the river or from a reservoir. Canal is classified into six types: nature of source of supply, financial output, function, boundary surface of canal, discharge and its relative importance, canal alignment. Classification based on natural source of supply. First one is permanent canal. Permanent canal is an perennial supply of water from its source, or it can be non-perennial source. Second one is inundation canal, which gets water at the time of flood only when the water level in the river rise above the average. Next, classification based on financial output. Productive canal. Productive canal is a canal getting revenue by supply of water. Second one is protective canal. Protective canal is a canal which do not get revenue. Classification based on function of canal. First one is irrigation canal. The canal which supplies water for irrigational purpose. Second was carrier canal. Carrier canal is a canal which transfers water to different reservoirs. Third one is feeder canal. Feeder canal is same purpose of supplying water to different for drinking purpose or industrial purpose. Fourth one, navigation canal. In the canal used for transport purpose. Next one, power canal. The canal which is used for power supply generation. Next one, classification based on boundary surface of canal. First one is alluvial canal, second one is non-alluvial canal, and third one is rigid boundary canal. The canal which have the surface of alluvial soil, non-alluvial soil, and rigid surface. Classification based on discharge and its relative importance is given network of canal. First one is main channel, branch channel, major distributive, minor distributive watercourses. These type of canal are given in diagram. Classification based on canal alignment. First one is contour canal, second one is watershed canal, third one is side slope canal. This type of canals are based on geographical and geological condition of surface. The diagram shows main canal, canal on ridge, distributaries, minor distributaries, major distributaries, source, etc. Canal alignment. Canal alignment consists of first one, the align in such a way that maximum area is served with the least length, and its cost including cross drainage work is minimum. Second one is shorter length canal has less losses of head due to friction and smaller losses of water due to seepage and evaporation. Third one is the alignment should be kept straight as far as possible. It will result in minimum losses. Fourth one is it should have minimum cross drainage work. Fifth one, it should not pass through the village, town, forest, costly lands, otherwise heavily compensation shall have to be given. Sixth one, it should be such that heavy cutting and filling are avoided. Seventh one, it should through passes the ridge so that both sides of canal can be irrigated. The alignment should be such that as far as possible a balanced depth of cutting and filling is achieved. The alignment should not be made in rocky, barrish or cracked strata. Balanced depth. A balanced depth is the given cross section only one depth of cutting for which the cutting and filling will be equal. This depth is known as balanced depth, as shown in diagram. These are few parameters. H is vertical height of top bank from the bed of canal. B. Bed width of channel. T. Top width of channel. These notations are from diagram. The formula for calculating balancing depth are given below. Cross section of canal. A canal is generally taken in such a way that its section is partially in cutting and partially in filling. In order to approach close to balancing depth, many times, however, the canal has to be carried through deep cutting or filling. A canal structure may therefore be in cutting, in filling, in partial cutting and filling, as shown in diagram. Components of canal: side slopes, berms, freeboard, land width, dowel, spoil banks, borrow pit. Components of canal. First one, slide slopes. Slide slope according to types of soil are given in the table. For clay soil, slope in cutting is 1.5 is to 1. Slope in banking 2 is to 1. In sandy soil 3 is to 1. In slope in banking 4 is to 1. And as given below. Components of canal. Berms, this is an horizontal distance which is left at ground level between top edge of cutting and toe of bank. When water flows in the canal at FSL full supply level, silt particles are deposited on the berms and make the final side slope to 1.5 is to 1. Freeboard, it is the vertical distance between FSL and the top bank. Components of canal. Land width, the total land required for the construction of canal is divided into two types: permanent land and temporary land. Dowel, a dowel is provided on the side of service road between the service road and the channel. Spoil bank, when the quantity of earth obtained from excavation or cutting is deposited near the cutting is in the form of bank is known as spoil bank. Borrow pit, when the earthwork is in filling excavated quantity at particular exit borrow pit are required to make good requirement of filling. Now canal lining. Canal lining is the process of reducing seepage loss of irrigation water by adding an impermeable layer to the edge of the trench. It is a treatment given to the canal bed and bank to make the canal section impervious and lined. Advantages: water conservation, no seepage of water into adjacent land or roads. The next one, canal linings improve command. Lining makes it possible to maintain high velocity in the canal. Thus, this flat slope raises the FSL in general and bring the high area of land under command which have not been irrigated before. Advantages of lining. Canal lining increases available head of for power generation. The canal section stable, prevent bank erosion and breaches, assures economical water distribution, reduces maintenance cost. Canal lining are of hard surface lining, earth type lining. Hard surface lining is further divided into cast in situ cement concrete lining, shotcrete or plastic lining, cement concrete tile lining or brick lining, asphaltic concrete lining, boulder lining. Earth type lining consists of compacted earth lining, soil cement lining. Types of canal lining: exposed and hard surface lining. Second, earth type canal lining, and third one is buried membrane lining. Exposed and hard surface lining, it includes all linings exposed to wear, erosion and deterioration effect of the flowing water operation and maintenance equipment and other hazards. The types are discussed before. Types of canal lining. Earth type canal lining. Thick compacted earth lining is durable and can withstand considerable external hydrostatic pressure. Bentonite has shown considerable promise for use as a good lining material. Buried membrane lining. Hot applied prefabricated asphaltic material, plastic film, and a layer of bentonite or other type of clays protected by earth or gravel cover are cheap lining. This type of materials are used for buried membrane lining. This some picture shows the cast in situ cement concrete lining, shotcrete and plastic lining, canal lining. Thank you.